So welcome back, everybody. This is the extension of last lesson on proofs. This is part two. So we have this proof, and we left off by saying like how we can prove it, right? And so here, if we have to prove that um, H is parallel to G, remember how to prove that. When we are proving two lines are parallel, there are only 5 ways we can do that, right? If two lines, G and H, are cut by a transversal, T or S, and corresponding angles are congruent, I find one pair of corresponding angles that are congruent. I find one pair of alternate interior or alternate exterior angles are congruent. I find a pair of same side interior angles that are equal to 180. I find one pair of same side exterior angles that are equal to 180. Those are the only 5 things, okay? So if two lines are cut by transversal and I have one of those 5 angle relationships, then the lines are parallel, right? So here we can do this um, proof in a multiple of ways. Okay, there's a lot of ways you can do this proof. And the way that I'm going to choose is I'm going to say that 4 is congruent to 12, right? Because they're corresponding angles. I can say that they're corresponding angles because T and S are parallel and G is my transversal, right? So if 4 is congruent to 12 and 12 and 13 are congruent because 4 and 13 are congruent because it's given, then I can say alternate interior angles are congruent. Therefore, these lines are parallel. Does that make sense? So I have a plan for the proof, right? And now it's just time for me to do the 2-step column proof. Yes. I cannot say 4 is congruent to 5 just yet because I don't know that G and H are parallel. That's what we have to prove. I can say 12. Notice that I said 12 and 13 are congruent, not because they're alternate interior angles, but because 4 corresponds to 12 and 4 also is congruent to 13. Okay? I didn't say anything about them being alternate interior angles. Okay? So your first statement here is angle 4 is congruent to angle 13 and T is parallel to S because it's given. Okay? The second step then, and I know the last step will be H is parallel to G. Okay? Remember that these 3 steps, right? 1, 2, 3, these 3 blanks is the most basic proof that you guys can do. I know you start off with the given, right? And the reason is given. And then the last step is that proof statement. Okay? Now we just got to reason our way through to get this. So the second step, like I said, I can say angle 4 is congruent to angle 13 or 12 because if 2 parallel lines, I'm going to highlight what those lines are, what lines are parallel. T is parallel to S, R, CBT, then corresponding angles are congruent. Okay? Because 4 and 12 are corresponding angles, they're congruent, right? Now I can say angle 13 is congruent to angle 4, angle 4 is congruent to angle 12, so I can say angle 12 is congruent to angle 13, right? What property is that? 13 is congruent to 4, 4 is congruent to 12, therefore angle 12 is congruent to angle 13. Yeah, the transitive property. Okay? And then now I can say, hey, look, 12 and 13, if you look at the picture, are alternate interior angles, right? And they're congruent. So I can say this because if two lines, notice that I put if two lines and I didn't put two parallel lines because I don't know that they're parallel yet. If two lines, I'm talking about line G and line H are cut by transversal and alternate interior angles, angles 12 is congruent to angle 13, are congruent, then the lines are parallel. Okay? If two lines, lines G and H, are cut by transversal and alternate interior angles are congruent, I'm talking about angle 12 and angle 13, then the lines are parallel, right? Okay? Again, there's multiple ways of doing this. I just chose one of the ways to do this proof. So this is the proof here. Okay? So you see how I reason my way through this, right? And just for this class, and just for my classes, my integrated 2 classes, if this is difficult for you, right? But you know how to reason your way through. Okay? Oh, 4 is congruent to 12 because they're corresponding angles, and 12 and 13 are, you guys can do that in your head, and you can write that in a paragraph, not in a 2-column proof like this. On an assessment, do it. Okay? Do it on an assessment. Write whatever you think is correct in paragraph form. Okay, just write it out. Reason your way through. Okay? Then I'll give you guys some of the points back. After you guys say the given, and the last step. Okay? Reason your way through in paragraph form. I don't know how to do a 2-column, but I know that this is true because this is this, this is this, this is this, and explain it. All right? Okay? Questions on this first one? I'll give it to you. Okay? All right. This one is not a, you know what? Let's do this one first. Let's do this one. Okay. C is parallel to D. Where's C? Oh, so those guys are parallel, and 1 and 14 are supplementary. So I can say measure of angle 1 plus measure of angle 14, oops, not 2, is equal to 180. Okay, and we got to prove that these two lines are parallel. All right, so those are my given statements. And I gotta prove that A is parallel to B. Okay, so I'm gonna give you guys two minutes to think it out, think it through. All right. Okay, go. So hopefully you guys got one. Okay, but there are a lot of ways you can do this. We just highlighted the fact that angle 1 and angle 14 are supplementary, right? So if angle 1 corresponds to angle 9, they're congruent to each other, and I can say that because these two lines are parallel. Okay? So they're equal to each other. They're congruent to each other. 9 and 12 are vertical to one another. So that means that they're equal to each other. So we're going to do this, okay? 1 corresponds to 9. 9 is vertical to 12. 12 and 14 are same side interior angles. So in this equation, I can substitute measure of angle 1 for measure of angle 12. Angle 12 plus 14 equals 180. So if same side interior angles, if two lines, A and B, are cut by a transversal, D, and same side interior angles are supplementary, then the lines are parallel, right? So that's what we're gonna do. But we're gonna do this in a 2-column proof. Okay, so the first step is going to be C is parallel to D, angle 1 and 14 are supplementary. I'm just gonna put sup, okay, for supplementary. That's given. And I know the last step is going to be A is parallel to B, right? So we got that. The second step is going to be angle 1 is congruent to angle 9. Because if two parallel lines, and I'll write out the parallel lines again, C is parallel to D, are cut by transversal, CBT, then corresponding angles these two corresponding angles are congruent. Okay. Notice that my then statement, I said this again, I said this yesterday or last class as well. So my then statement is always going to be my statement here. Okay. So since I got that, I can say that angle 9 is congruent to angle 12 because vertical angles are congruent. Step 4, I can say that angle 1 is congruent to angle 12. Why can I say that? Angle 1 is congruent to angle 12. What's the reason behind that? It's a transitive property. Okay, or substitution if you're going to use substitution. Step 5, I'm going to say angle 12 and angle 14 are supplementary, right? Now I know angle 12 and angle 14 are supplementary. That is substitution, because I'm just substituting, right, step 4 into this statement here. Okay? And now step 6 is my proof statement. If two lines A and B are cut by transversal, D and same side interior angles are supplementary, then the lines are parallel. That is my proof here. Okay? And notice that each and every little step is written down. Okay? There's no step that I did not write out. Okay? So that's how detailed you have to be in a proof. All right? Cool. Actually, you know what? I just want to skip that one. Let's do this one. Okay, we have two triangles. And we're given the fact that AB is parallel to CD, and angle 2 up here is equal to angle 6. We must prove that BC is parallel to DE. Okay, so take a couple minutes. This one's a little more difficult, so take as much time as you need to try and figure this out. So here is our plan. We found out that 4 is alternate interior to angle 2, right? And I already know that angle 6 and angle 2 are congruent to each other through the given statement. So I know that 4 is congruent to 6, making these lines BC and DE parallel because those alternate interior angles are congruent. Okay, so we're going to write it out. The first step is going to be our given statement, AB parallel to CD, and angle 2 is congruent to angle 6 because it's given. The last one, BC, is parallel to DE. Okay. The second step then is going to be that angle 2 is congruent to angle 4 if two parallel lines, AB is parallel to CD, are cut by transversal, then alternate interior angles are congruent, right? So if I know that, then I can say 2 is congruent to 6, 2 is congruent to 4, angle 4 is congruent to angle 6 through the transitive property. And then the fourth step would be this. If two lines are cut by transversal and alternate interior angles are congruent, then the lines are parallel. Okay, so that's my proof for this one. Okay, so we're always going to come out with two, if we're proving parallel lines, we're always going to come out with an angle relationship, right? That we concluded that it was true without using the parallel lines at all. This is transitive. Most likely it's going to be transitive. Most likely it's going to be transitive or substitution. Okay. But I did not use these parallel lines, B, C, and D, E, anywhere above it. Okay. That's a key part that you have to remember. Cool. Okay. So that's it for today, class. What I want you guys to do for homework is